So I'm going to kind of now, I think the easiest thing to explain this is to show you it in action, and then I'm going to show you how you might take that wee pathway we drew this morning and parameterize it and understand the results. So first of all, open this diagram within. Okay. So this is just a big grid, okay? And what we have within this big grid, so we have an input here, okay? And you can see on that edge, I've put 1,000. So I've actually written onto the edge 1,000, and that 1,000 means there's 1,000 tokens here. There's also 1,000 tokens up here, and there's no tokens throughout the whole of the system. Okay? It's just a diagram of a random grid, and actually the interesting thing about this is that when I made this grid, I thought it was going to work in an entirely different way than it actually turned out to work. Okay, so it's a grid. It's then drawn in YED, and of course what I'm representing here is more similar to the concept of a node, a Petri net, classical circles. I've drawn them as blue squares, but essentially it's a bit like in a classical Petri net where you've got black rectangles and blue squares rather than round circles. But it's drawn in a bipartite graph. Right, so our favourite tool, all familiar with this, I don't need to show you this now. Okay, so this is called a graph, and when you save from YED, you're saving a GraphML file. So this is just a file format which contains all the information that you put into that diagram, all your notes, etc., etc. If I drag this in here, you can see, so I've dragged it in, and it's asking me, this looks like a signaling Petri net, and the reason it knows it's a signaling Petri net is because those black rectangles it recognizes as transitions, and because it recognizes that transitions, it recognizes that I must be putting into there a diagram which is drawn in this way, and said, would you like to run an SPN simulation? Yes, please. Okay. When you come across this window here, we have the concept of time blocks, and we have the concept of runs. Now, as I mentioned, I'm also going to calculate the variance that we see here, and I'll just for now say run. So this is a big diagram, I think you appreciate. I don't know quite how many number of nodes, I'll count those in a minute. And it's going to run these simulation. It's calculating the error associated with those simulations. And done. Okay. So open animation window. Okay, so let me just go here. So there's our diagram. I'm going to make the edges just make them a bit darker and colour. Okay, so there's our diagram in BioLayout. Okay, now in 2D, 3D. And now we've run the simulation. So if I put my cursor over a node, we could begin to see something of the token flow through that system. Does that make sense? And when I start the animation here, so let me see, I'm going to make it quite fast, 4 seconds per, and I'm probably going to need to make my node size a bit smaller, but we'll see. And I'm going to, so this value here, this 1720, is the maximum number of tokens at any point during the simulation, and that sets our maximum, and so that will be the node going big. So we're going to use that same animation system that we used with gene expression network, was when tokens flow and they accumulate, they'll be big, and just going to drop that down here, and we're going to say start. So here's the tokens flowing along. Now this is a feedback loop. Now the tokens are coming in here, and we can see the tokens being distributed through the network in this kind of following this path that we've defined there. Okay. Now you'll see this cut back in a moment, I think. Maybe it's not going to do that. But you can see how this has now dropped down. Actually, what I'm going to do now is I'm going to rerun that. So let's just go back to running an SPN. I'm going to drop this down to 50. And I'm going to make this more, so we'll begin to see something more of the behavior. So let's run that again. So we're doing 1,000 time blocks, so it's going to take a bit longer. So we're going to run it 1,000 times over. And then we're going to open the animation control, and we're going to drop this down again to maybe 200 and start the animation. So here it comes again. Down. Now this top one, there is no feedback on it. So basically this is just kind of constantly feeding in tokens and feeding the system here. Let me just drop that down here. Stop animation, more. I'll drop that down to about 100. So because we're feeding in tokens here, and they're just randomly sort of spreading out through the network based purely on connectivity, then essentially they're getting lower in number. I'll make it even faster. Go up to 20 time blocks. So you can see it go there. Okay, I've probably lowered it here, but you'll see this turn off in a moment, I hope. It's feeding back properly. In fact, I've probably overdone. Let me just try that again. Start from time block 1. Oh, maximum value. No wonder it was there. It was set up at 150, let's see. It was only at 1 before. So let's go down there. And you can see how this is now flashing. That's the randomness. So it isn't, the answer isn't even. It's actually fluctuating based on the firing transitions. This is fired off now. But we can see this one is there. So we're getting a distribution of tokens spreading out from this point. They're coming here, and they're basically thinning out as they flow through the network in a kind of almost random fashion. So we're beginning to understand how these tokens feeding into the system are being distributed. And we can certainly see in this case how random the flow is. So if I stop that again, so that we can make certain assumptions here by running this algorithm. And let's say that we're going to more use so in this deterministic mode, we're rather not going to make the firing of tokens random. We're going to say we're going to take half the number of tokens that we had before and move them forward. So we're just making a different assumption, and we're going to do this again. So rather than uniform distribution of tokens, and you'll see now that actually the token flow is less random than it was previously. Okay. Go back to 150. That seemed to work quite well. Start that again. Fire back. This loops back. And you can see it's kind of slightly less random than it was previously. It doesn't. So if I go on any given node, then let's take one of these guys here. You can see what I've got is an oscillating system. So tokens are flowing down here, they're feeding back, they're sitting on this inhibitor, they're blocking that particular transition, and so that shuts tokens through the system, and so you get this drop. Then of course, because you've blocked this flow, because it's blocked at this point, then these tokens basically just burn out, and then it opens up again as we've lost tokens, and what you get is an oscillating system. As compared to up here, where we have no feedback, and we just have a straight line full of tokens going in and coming out. Okay? Right, so I just wanted to show you that a little bit about how you can visualize flow through this thing. Let's apply this now to biology.